So today we're going to talk about equations with variables on both sides. And when it says both sides, it means both sides of the equal sign, right? We've got an x over here, we've got an x over here. So yesterday you guys were practicing when you only had a variable on the left or the right side.
Yeah.
Today we've got it on both sides. So if you were to take out your flip book, you don't have to right now, but if you were to, you would be on the isolate the variable page. And if you flip open to it, you would see you have a variable on the left and a variable term on the right. So then it's rearranging to get all the variables on one side. Remember, you can choose if you want to go subtract -4 or subtract 4 or subtract 21. But my advice is to always choose the one that has no negatives, if it's possible. Got our wall of equality here. Okay, so what you guys are going to do for this is you're going to look at number 1, and then on a piece of paper you're going to write number 1, and you're going to put number 1 in the box that you're doing. So the problem number on your paper, you're going to have to number it here, right? Remember, the goal of a maze is start to finish. So you're going to start, you're going to write the equation. So we have 6 minus x equals 5x plus 30. We're going to draw our wall of equality. And now we're going to start shifting everything so that we have all of our variables on one side and then just numbers on the other side. Okay, for some reason I have students today, and again, I do blame this on the fact that you guys haven't really had full math instruction for a couple years, and they want to get something so it looks like this, 5x plus 3 equals, and then there's nothing else over here, it's empty. That can't happen. You can't put everything on one side. Your last step should always be something with variables equals a number, or a number equals something with variables. You have to have something on either side of that wall of equality. If you don't, then you did something wrong. Yes, sir?
Can't you add 6 on both sides?
Well, we're gonna walk through that together in just a second. Okay, does everybody understand that you have to have something here and something here for your last step?
Yeah.
Okay. If you don't, you need to come see me and we'll talk about how you got to the wrong location of things. All right, so the first thing we're going to do here is we're going to pay attention to our terms that have variables. We want to get them all either on the left or all either on the right. So you guys know that once you cross this wall of equality, you have to do the opposite operation. There's a secret 1 hiding here. Some people feel better if they put the 1 there. That's fine. You don't have to, but some people visually, it helps them remember that that's a 1 in front of the x. So I can either add 1x to 5x, or I can subtract 5x over on both sides to here.
Add 1x, subtract.
So you can subtract if you want, but then you have a negative coefficient, and negatives are no bueno, right? They just make things worse. So I'm going to add 1x to both sides. Remember, we have to balance. So if I add it here, now this is gone, then I added it over here. So now I have 6 equals 6x plus 30. And now I'm at a 2-stepper, step 1. So 2-stepper, step 1 is subtract or add so that you have all variable on one side, all number on the other. So I have to subtract this 30. I'm forced to do that. I can't subtract 6 because then I end up with everything on one side, and you can't do that. So I'm going to end up with a negative, but it's better than having both of them be negative. And then 2-stepper, step 2, my final step. What am I going to do here? Mia? Divide 6 on both sides. And I get -4 equals x. Now, Again, if you cannot remember the positive and negative rules for multiplying or dividing, what should you do?
Oh no.
Use
I can't remember.
a calculator.
Calculator.
Yes, get out your Desmos calculator on your iPad and use it. There's no shame in checking your work. If you don't remember that a negative divided by a positive is a negative value, put it into the calculator. Now, I don't have Desmos on this one yet, but I'll show you that if I was just using this calculator, 24 negative divided by 6, it's going to tell me it's negative 4. So I don't have to overthink it. Okay, so for number 1, I'm going to color in, I know it looks kind of weird, but it's like a smushed arrow. I'm going to color this in. And now I know I'm going to do this problem for number 2 because it's pointing to this problem for number 2. So then on my paper, I'm going to go over here and I'm going to copy that equation down.
Do you have to color the colors?
I only do it so that I don't get pencil on my pinky when I'm writing. You don't have to. Sorry, Roman. I already started it for you. Yes.
Is this homework?
It's not.
Okay.
Nope.
Minus.
So now I've got my second equation ready to go. I'm going to draw my wall of equality. Am I going to subtract 4x on both sides or subtract 3x on both sides?
3.
I'm going to do 3x so I don't end up with a negative x. So now I just have 1x minus 8 equals 2. And if you don't want to put the 1 there, that's fine. You can just put x. And I'm basically at 1 step because the x is just x.
You have to add the 8.
I am going to add 8 to both sides. So now I have x equals 10. That is my answer. I look at my maze, and I see that that is a choice. So I color that in, and now I know my next problem is going to be this one. So I'm going to put a 3 in that box. It's positive because it's just a 2 plus 8, so it's positive 10. Okay, the only other one we're going to do together is the one down at the bottom, kind of in the middle, not the total bottom, but has decimals. We're going to do this one together. I'm not going to number it because I don't know what number it will be when you're working your way around. So that is 0.4x minus 8 equals 9 minus 0.6x. Yeah? Yeah. Okay, so there's a couple things you can do with decimals. Remember we left that part blank in our flip book? You can either just solve it with the decimals using your calculator, easy peasy, or you can clear the decimals, just like we would clear the fractions. So by clearing the fraction, we make the fraction so much bigger so it becomes a whole number, right? So 1/3 becomes 1, everything else gets multiplied by 3, and so on. Similarly with decimals, I want to make these two decimals whole numbers. So what do we have to multiply these by so it becomes 4 and 6? 10. Yep. Right, all I need to do is, okay, I'm just going to shift the decimal one place. So I'm going to multiply everything with distributive property by 10. So now I'm going to have 4x minus 80 equals 90 minus 6x. Again, you can just leave the decimals. You're still going to get the same answer. It's not going to change the answer. It's just some people don't like decimals, so they get rid of them. I genuinely don't care what you do, as long as you get the right answer, and I can see your process. So now I'm going to draw my wall of equality. Am I going to subtract 4x from both sides or add 6x to both sides? Sure, because I don't like negatives. So this is now gone. Now I have 10x minus 80 equals 90. I have a two-stepper step 1, so what am I going to do? Plus 80. This is now gone. 10x equals 170. X equals 17. How are we feeling?
Good.
Okay-ish?
They seem easier than the one step. For some other reason.
So it's kind of like when we talked a little bit about long division, right? Once you learn like the steps, nothing really changes. You're doing the same evaluation, evaluate this step, evaluate that step, over and over and over again. It'll turn out eventually, like when you're in high school, like, this is so boring because it's the same thing over and over and over again. Right, Amy?
Are we gonna end up doing every single problem?
You will not.
Okay.
Nope, absolutely not. So then I would go down here on this one, and I would color this in. Okay, so eventually you'll get to that problem. Okay, you guys have 9 minutes to work by yourselves.